Hello. Today we are talking about potential and chemical energy. You probably heard of this before, but we want to put it in the context of what potential and chemical energy looks like in chemistry. Okay. So what I've got here are a couple of molecules. So I have a typical gasoline molecule and then diesel molecule over to, that's the longer molecule here. It shows what they're made up of. We have carbons, which are the dark blue spheres, and hydrogens, which are the green spheres. And gas molecules are said to be energy rich. And the reason is that the bonds holding the carbons together, those bonds are made up of energy. So that energy is just sitting there. It has the potential to do work. So right now we're talking about potential energy. For our case, that potential energy is stored in the bonds of the molecule. And the bonds of the molecule, you can see, are the lines that connect each of the carbons. So there's just energy sitting there in the molecule ready to be used. That's what potential energy is. It's energy that's not being used, but it's there. It's like a battery, right? Just sitting there. That's what these gas molecules are. If we break the bonds, we can release that energy, okay? Release energy. Now, when we break those bonds to release energy, then we can get things like this.
Almost had contact. Petrucci won the title line, picked up the Vizioso, he picked up Marquez, and after all that, Petrucci still leads.
Petrucci leads, but Marquez is making shapes. He's trying to find a way through on the number 9.
Okay, so that was a good example of potential energy being converted to kinetic. So, with the MotoGP bikes in that race, the potential energy was locked up in the gas, right? So when they start to burn the gas, that breaks those bonds and that energy gets released. Now that energy can be used to make the motorcycles go, which is kinetic energy. Energy released by the bonds and can now do work. So the work that we saw was making the motorcycle tire, back tire, spin, which then obviously propels the motorcycle across the pavement at really high rates of speed. So potential energy gets converted into kinetic energy. And let's look at some other examples. We mentioned gasoline because our first unit was concerned with gas, burning of gas, combustion of gas, and releasing energy. But there's other examples that are important to think of too, that can help us visualize potential energy and kinetic energy. All right, I got another one for you. So potential and kinetic energy, we see it here. I'm moving this bowling ball up to my chin, and now gravity is giving it the potential to do some work. It has potential energy in it because gravity is trying to pull it down, and it's staying stationary. If I let it go, that's going to be kinetic energy as it swings in its arc, okay? So potential energy, kinetic energy. Okay, in this example, I want to light the goldfish cracker that I have here and get it on fire. Now, the reason I'm using the goldfish cracker is the goldfish cracker has a lot of sugars, it has a lot of carbohydrates, so very energy rich, okay? Now, that energy richness is what's going to allow it to, when it burns, and our system's doing the same thing in here, it'll burn and release energy. And if I let it go long enough, it would be enough to start heating up this water. The small amount of water can be, Okay, thought I was going to get into a little trouble there with the fire and the smoke, so I had to end that video a little quicker than I was expecting. But just to finish it up, the sugar that you see here, there's many types of sugars and larger types of carbohydrates, but the important thing that you're seeing is that the main structure is carbon, right? Now the carbon atoms are able to make 4 bonds. And because of that, they oftentimes in biology serve as like the backbone of molecules. And we see this in carbons and carbohydrates. And each bond has the potential energy to do work. Just sitting there, it doesn't do anything. It has the potential to do the work. Then we either eat it and start breaking it down, or we burn it, which is a similar process that's going on, where whether we're digesting it or I'm burning it there in my example, I'm breaking those bonds, releasing potential energy into kinetic energy. So the kinetic energy is released, and then it can go do something. For us, there's various life functions that happen in our body that need energy. We need to maintain a certain temperature all the time. So energy goes towards doing that. In my example there, I could have used that energy that was being released from the cracker to start boiling that small amount of water. Okay, so potential energy, kinetic energy. Hope that helps.